I see the crowd is kind of reduced in numbers, but I promise you this will be worth your while. So what I'm going to share with you today is some of the results we have coming from our R&D. So these are actual results from toy models that we've built, and hopefully if there's engineers in the audience, you'll get something concrete from this presentation. Now, obviously, agentic does all of the things that are nowadays the topic of discussion, like automation and such. However, what I'm going to share with you today is something that's coming from R&D, so research and development, things that we've tried, and we want to see what can be done with regards to orchestration of agents in companies. So this isn't something that you can apply today, but it is something that you can apply in 2-3 years' time. So obviously, automation, chatbots, all of those things, yes, they can be done, but we want to see what the models, current generation models, are actually capable of today. So I'm going to start with this somewhat abstract chart. Yeah. Are we early? I can't, yeah, let's...
No, it's not. Okay. You're right.
Yeah, I'll hang out. I'll hang out for a moment. No problem.
Let's just give us a minute if that's fine with you. Yeah.
Thanks for that.
Thank you for that.
I'd rather the room filled with people than be empty. Anyway, like if there are engineers, how many engineers are here? Awesome. You'll get concrete stuff today. Not that I haven't been here before, so I don't know if others did that, but there's going to be technical talk, but I'm going to try and make it available for everybody. Usually there's last year I kind of went too futuristic, so this year hopefully this will give you some sense of what is done in practice, especially in R&D. So yeah, let's wait a minute or two. Yeah, we can go to Q&A. Yeah, if you have questions, please go ahead.
I'm not sure if this relates to your expertise, but Elon Musk came out with those humanoid robots.
Oh, yeah.
And I'm curious, what are your thoughts? Because you said you're at the R&D stage. Mm-hmm. Does your company or your software has anything related to do with actually creating robots?
Robotics, okay.
Yes.
So I didn't want to do a whole bunch of introductions on what agentic does, because I think everybody kind of hates that. But we're a service-oriented company, so we resell for other clients. And yes, we did automation, we did embedded engineering. Some of that was in robotic automation, but not necessarily building robots. Now coming to robotics itself, the issue with that is you can only do that if you have a lot of spare money for R&D. So by a lot, I mean like probably in the hundreds of millions. Yeah, Elon Musk does. Now, in terms of what's doable with robotics, I can answer some of those questions. The issue earlier with robotics is that you always used algorithmic approaches to solve these tasks. And that's why all the demos of robots are so clunky, because they don't actually understand or integrate the information that's coming from sensors. It's almost like it's hard-coded what they're going to do. And if you see some of the more recent examples, for example, from Boston Dynamics, you'll see that those robots are now gaining some ability to reason about the environment. But still, what's kind of revealing is if you can show the robot's point of view, and by the way, just tell me when I should begin this presentation, but if you can see the robot's point of view, it's probably because some of those things are still algorithmic, right? Because if you were just using neural networks, like Tesla full self-driving, that's primarily neural networks. So you can't really see what the model sees. And because in the Boston Dynamics demo where the robot moves things, it's obviously a layer of object recognition, and then behind that there's a hidden layer which we don't know what it's doing. But it's a hybrid system, that's what I'm trying to say. The way I see it happening in the future is most of it is going to be neural networks, so it's going to be much more difficult to tell what's happening in the quote-unquote brain of the robot. So the same techniques Anthropic is using, if you're following that studies, what Anthropic is doing, they're trying to figure out representations of these large language models. Those are, that approach ought to be used for robotics if you want to see from through their eyes. But as long as we can see objects being detected, that means that there's an object detection layer happening there.
Just a quick question. With the objects being detected, because when he said he's going to roll out like some of those humanoid robots, they're doing dishes, they can clean, like everyone's just kind of freaking out that this is great, but then it's replacing everyone's work at home. So when you say, again, I'm not an engineer, but I follow a lot of things going on. When you say near future, are you saying like the next 2 years or 5 years? Because Elon Musk says he's going to roll out these like next year or the next 2 years. It will be in every American home.
I feel like...
Or he's just agitating. Yes.
I feel like maybe multiplied by 3, his predictions. His predictions usually come true, it's just he's very early in them. So yeah, obviously, to perfectly genuinely answer this question, I would have to have access to the same information he does, which I don't, to be perfectly frank. So there might be some innovations that are happening, but what I'm quite convinced is that they're going for the full neural networks approach rather than the hybrid one, which Boston Dynamics is doing at the moment. So whether they're going to replace everybody in the next 3 years, I would say it's quite unlikely. But 10 years, you should get worried, probably. Cool. Can we begin? I'm not. Oh, it's 10:54. Oh, there's 5 more minutes. Please.
It's 5 minutes to 11. So I've just checked. So if you can start, you can start now.
I can start. I can start. Sure. Is there anybody new to? Should I start from the beginning? Okay, let's do that. Let's do that. So, quickly summing up, I am going to share things that are coming from HTech's R&D. So, there's more people coming. So, we have different branches for this, and we also have automation teams in HTech. But what I'm about to show you is coming from R&D. So, we're testing current generation large language models and large multimodal models. To see what they can do besides just chat. And we want to see whether we can do any form of real automation or real agency with these models. And hopefully that this is going to illustrate to you what I'm talking about. So right now, technology that we're using is pretty much a proxy between people. So people are talking and using technology to facilitate that communication. That's what's happening. And it's very, very easy, this is the laser, it's very easy to delineate between what consists technology, these are the square ones, and what consists, teams, people. So people interacting, that's just a team, and then technical services communicating with one another, that's technology. But as you integrate more and more intelligent systems into technology, that becomes more difficult to delineate, right? Because you don't know what's on the other side necessarily. These things are passing Turing tests, so it would be very difficult to ascertain, especially in the context where you have a teammate who's an agent in a way, what a team is and what's just technology. And where I see this scaling further is the scenario in which it's completely irrelevant. It's not just that technology is facilitating communication between people, it's that people are facilitating communication between different digital agents. So in that kind of future, it's very difficult to not only delineate, but to separate at all what is technical and what is human or biological. It's not just like human in the loop. It's more like all of it is a single paradigm. And I'm going to show you why I think that's going to happen from a technological point of view. So I don't want to do some sci-fi thing here. I'm going to show you some of the results we have and why we think it's reasonable. So here's the typical conversation everybody has about proactive agents and chatbots. The typical conversation is, okay, right now we have chatbots. The human issues a query, the chatbot responds, processes, returns a message, and it's always driven by the human. However, what we want to see in the future is agents. These systems which have a degree of autonomy in which they can initiate conversations. So they'll talk to you first, they'll send you messages first. Even if you're not talking to them, they're doing something. In the classical case of chatbots, you're the initiator. Okay. However, that's really just scratching the surface. The issue here is when we talk to one another and actually are solving problems, what we're doing is we're not just using text. I'm going to wait for people to come in here because we're now just getting into the actual stuff. So when you're talking to somebody, let's say you're working in a team and you want to solve a problem, it's not just that it's not just textual exchange. What's happening is you're constantly changing the context of what you're doing. So if it's a team, you might take out your notebooks, you might use a whiteboard, you might invite somebody else if you realize, okay, we need somebody else's help for this, their expertise in whatever niche it is that you're doing. You're going to be changing what's happening all the time. That kind of thing is just not replicable through mere chat, right? It's not a turn-based conversation. Every interaction is a renegotiation of the terms of the interaction. Do you see what I mean? We're trying to figure out what is the best way to do this kind of communication to solve our problem. So how that would manifest in a kind of in a digital environment, what's going to happen here is you're going to have human and digital agents interacting, but the output is just not going to be simple text. It's going to be probably some form of HTML. So basically, UI is going to be rendered to you as you go. And this is one way to do it. And I'm going to explain to you very shortly how we would do this technically. So there are kinds of messages that agents exchange to negotiate the formatting of the subsequent conversations. Okay, that's what we were going for. So first of all, there's a message exchange. Then the agents figure out what is the best way for us to communicate. If this is agent to digital agent, then you perhaps want to do some sort of JSON or some compressed format. Otherwise, you want to continue doing natural text. But whatever happens here, those elements that are formatted can be rendered in accordance to what agent is reading that information. Okay, so let me start building more and more complex systems. First of all of the LLMs right now, most of them, are fine-tuned for turn-based conversation. Okay, so and that's kind of hindering multi-agent communication. If you have a team of people who are communicating, you want to be able to quickly identify them, and this costs tokens, right? If you're doing this in traditional ways, all of the user messages are going to have headers which are describing which agent this is coming from. You're going to have information added to the system prompt, which is informing the agent how this is going to happen. And there's a lot of unnecessary boilerplate here that's happening. So one simple way to mitigate this is you fine-tune user messages. So you fine-tune for multi-agent conversations, which means in a way you're inheriting a message type. If you have 5 users in the system, you'll have user 1, user 2, user 3 message types instead of user message type and then header. Like header is now baked into the identity of these messages. And that way you're reducing the token count. Cool. That's a rather trivial example, but that's how you might mitigate it to alleviate this tension of the token count. However, we can do better than that. One idea is to fine-tune for XAML. Why? And XML is just, it's a form of structured language. It's a specified formatting. Now, if you fine-tune for this, what's going to happen is you can now use XAML attributes to identify users. This way, yes, you can do turn-based conversation, but you can do much more than that. This is an example of how these messages would be exchanged, right? But another thing you can easily do is transform XML to HTML, right? HTML is just a subcategory of XAML. In this way, not only can you render the entire conversation, but you can also render other kinds of elements from that XAML into the user interface that whatever user is using here. Okay, so this is how that might be facilitated. You have one agent communicating to one. By the way, this is all from a toy model. We experimented with this, and we know this is doable, right? There are some hurdles to overcome, but current generation models can do a lot of what I'm talking about here. This is why I'm saying this is coming from R&D. Like, a lot of this is not ready for production at the moment. No large language model today is capable of fully going through all of this, but they're very close. Okay, so here's what you do. Your agent inserts a XAML element into this shared, we call it prototype, and then that, because the target ID of that element is matching the ID of the agent reading it, that element will be shown in the view of that agent. Do you see what I mean? So messages are just proxied through these elements, XAML elements here. Okay. In effect, the entire conversation, let's say, is stored in this global prototype memory. It's just a huge chunk of XAML, and all of the individual agents are just having views to that chunk of XAML. Okay. So, give me a sec. Okay. So, but something has to, like, if we move to this one, you have a global prototype memory, and you have these different agents accessing that, pulling only those elements that are somehow related to them. But when I say the agents are pulling that, there has to be a system that orchestrates all of this. And this is where we're coming to the intelligent operating systems that the presentation is titled with. Here's what we experimented with. We have a kind of agentic runtime, we call it. It's a dual virtual machine. It's something that simultaneously interprets a piece of XAML both as deterministic code and as prompts. So this agentic program prototype, conveniently acronym to app, is just a piece of text formatted as XAML that has different elements. You can have data elements, code, instruction, definition, and so on. Some of these elements are written in natural language, some of them are written in code, in say, C#, Python, whatever. And you have the underlying interpreter, you have a bunch of LLMs that can run this text, or you have a bunch of deterministic interpreters, say C#, Python interpreter, whatever. Okay, and they are switching contexts. So here's the cool part. When you implement this, you can have, this is an analogy to operating systems. We haven't implemented this on Metal, so it's not bootable, but it's a virtual machine. Like, we have toy models that experiment with this behavior. What's cool is the runtime is going to be doing the context switching. So you could have an entry point that's in the instruction element, or you could have an entry point in the code element. The cool thing is, because the runtime is catching the outputs of each of the agents, it's able to do context switching. So you can call code from instructions. You can write a thing in natural language and call a function that's written in, say, C#. And then that function can call another instruction, say C here. I won't go through the actual illustration here. Engineers will see what I mean. But what's going to happen is it's going to switch contexts. And the runtime is in charge of transforming the relevant context. So for an LLM, it's going to be just context window is going to be filled with actual text. And when switching to deterministic processing, the object state is populated. So basically all the stack, all of the memory state in traditional programs would be encompassed by this. But here's the most awesome ever part. You can do this with people as well. Like you don't have to know who is the executor. So when the runtime knows that the receiving agent is human, it just switches to a UI, right? So when, say, one of these messages was run on let's say a piece of code is calling method named C. And let's say that there's an agent who is processing that C, and that agent is a human user. What's going to happen is it's going to invoke a kind of adapter user interface in which this user is going to interact, right? So it's switching between kind of three modalities. One is textual, one is code, and one is whatever it is we humans use as primary modality. So, and this is quite doable because of that underlying XAML structure, okay? So here's what we do here's how we do it technically. You have these different tags, different elements in XAML, and now we're talking about LLMs, obviously. As the LLM is outputting its tokens, it's building out this output, and as soon as a properly formatted XAML tag is outputted, we match that. We have a parser that matches that, and then interprets the meaning of what was outputted. Okay, so you take that, you parse it, and then you execute. When I say you, I mean the agentic runtime. It selects the appropriate interpreter for what is being shown here. And here, this is showing specific, like, code execute true. This means as soon as the parser matches this tag, it's going to execute whatever the code is. And the cool part here is you can use this to do system calls and whatever else. The cooler part is any agent can do that. So if you're typing through Teams, you can actually issue that same thing on this agentic runtime. However, you as a human, you wouldn't type the call, you would just click a button, because you will have a rendered UI that's corresponding to that call. Do you see? You don't have to code for this. The agentic runtime is just rendering code or this agentic program prototype into something that's discernible to you. Okay, so give me a sec, please. Additionally, because we have to account for thinking, what's going to happen here is you can also have chains of thought working normally here. Anything that's encapsulated in a process element, process tag in XAML, is just not going to be directly, immediately processed by the parser. It's just giving the model time to kind of figure its own way out to the final tag. And then once it outputs, here in this case, data 4, then that's going to get inserted into the shared prototype. Okay. However, it's multimodal. So what that means is every agent type has its own adapter table. What's an adapter table? It's a way to render data elements. Because let's say you had an LLM that supports audio. You don't want to have that audio translated to a kind of byte stream in text. You would rather supply it as the proper modality. So the agentic runtime is going to invoke the appropriate adapter for the current agent. See, so if there's audio, then that audio is going to be rendered in the appropriate way. So if the LLM supports audio, that's going to be passed through JSON. If it's a human viewer, that audio is going to be passed as a URL to the audio tag in HTML. You're just going to see a playable element. And if the LLM is strictly like a language model, it doesn't support other modalities, what's going to happen is it's going to render to a data tag, data element, using some sort of a data transformer, right? Perhaps you could do audio recognition, whatever you're using in the background, but it's in a way a hard-coded adapter. And when I say hard-coded, that's because we're towards the middle of the presentation. Later on, you'll see why it doesn't have to be hard-coded at all. So yeah, that's how we handle that. Here, I supplied a bit of some of the nuggets from the actual implementation, because when you're adding information, it also depends on who is adding it. So if I'm a human agent, might move a file over, but a digital agent might just render text. So we use data type and data adapter depending on whether we're transforming from a type or to a type. I'm sure if somebody has a question about that, I'll answer it later. That's a bit too technical at this point. So what we can do, though, is all of these adapters for human agents are UI. So underneath everything, you have agentic runtime, and then you have these agent prototypes, the apps I mentioned before. But the cool part is other agents are just going to use their interfaces, their adapters, to communicate with this agentic runtime. And this is one of those things is doing syscalls or calling other agents through syscalls. But for humans, it's just going to be you're using an IDE, you're using your Office programs, your communication mechanisms like Teams, Slack, whatever it is you're using, and that's hooked up into this agentic runtime. But the way we see it in the future, like 5, 10 years from now, the traditional software is not going to, the front end is at least not going to behave the same way. Because the front end is going to be constructed ad hoc to some degree. So, okay, so I'll give you some of the examples of these agentic program prototypes. You could have a piece of code, like a Python piece of code encapsulated in a XAML element. You could have instructions, so it's either full code, full natural language, or a combination of these. And obviously for large language models, you're going to use these definition tags to elucidate what it is that this agent should be doing. But here's also another interesting part. If you completely abstract away the type of agent, then in a large company, this operating system becomes also the company orchestration tool. Like, that means that the definition element for a human will render to a legal document. We're talking 10, 15 years from now, but because that's the way definitions work for people, that's how we define our roles, this is going to be rendered in that way. So that obviously this is now getting into the hypothetical, but this is why we're doing this toy model. We're trying to see whether this is doable. If it's not doable, then it's sci-fi. But we're seeing that it is. It's quite close, and I'll mention towards the end some of the issues that we're into. But the most interesting part here, and where I think it's departing from traditional operating systems, is the level of polymorphism that's happening here with these agentic program prototypes. They're polymorphic at least in 4 different ways. The code you write is data. Everything can be interpreted as just input data. Second, it's code. Like, you can interpret every tag, every element as source code that can be run on a deterministic interpreter. Third, you have, obviously here is in other order, but you have prompts, and finally you have user interfaces. Because we're using XAML, it's also a definition for front end. Cool. And not only that, you have a different kind of polymorphism because it's just text. What's running as a process is also a program, and this is a kind of, different way of seeing things, especially if you're used to traditional, you compile a thing, that's a program, then you run it, it's a process. Here it's very difficult to discern what's working memory and what's not. The memory model is going to change completely. I didn't have time in the course of this to add memory management. That's also a topic for another day. It's really interesting. But the necessary part here is that you can fork these programs. You can create different versions of them. There's a good reason to do this, by the way. So you just copy it, and there's one stream that has one version and another one for the other. The reason why we want to do that is because you can do that variation, you can test out different pathways. And here's where we come to the actually useful thing, and that's task execution, because we assemble in a company in order to solve a task, right? So a task is just a transient, temporary definition of what we're doing at the moment. be it a single person, a group of people, whatever. It's changing, but it's an extension of one agent can issue a task, be that a human or a digital agent. It issues a task, defines the task. The task has its own definitions, perhaps paraphernalia, files, data, elements, all of that, and that is injected into the relevant agents. Okay, so those agents now start working on that. They have their own definition, their own job descriptions, if you will, and then they have the current task. What is it that they're currently working on? Have they taken a task from, I don't know, Jira or whatever it is you're using, or their superior issued a task? Whatever the case may be, it's encapsulated in this task, and the task itself is managed by the agentic runtime. Okay, which means that multiple different agents, chains of agents, can run on a specific task until that task is completed. And obviously, you'll have ownership, inheritance, and all of that. The issuing agent is the one that can close the task. So you'll have a loop running through all of these calling agents. They're going to be doing their chain of thoughts, whatnot, and then that's going to come back. And all of this is facilitated by the agentic runtime. The cool part is you can do variations in each one of these because you can fork these programs. So what happens is you run one of these and you run a variation. And once those are done, you can do them in parallel. And once those are done, you ask the issuing agent to complete the task. Basically, you ask it, which one of these is better? And they select one. And based on that, you say, okay, let's reward this kind of agent in favor of the other. And the main hurdle today with this, it's slow and expensive. It's really expensive to do this at the moment, but it's doable. But here's where we jump to the next level of this. And the entire company intelligence now becomes this agent orchestration operating system. It's not your ecosystem in your company becomes melded with software. Here's an example. Let's say this was task A run and task B run. And the only difference here is that one of the agents was exchanged with this one. I'm deliberately not saying which one with which. So let's say there was a digital agent misperforming, or let's say A was performing better. That means this particular task is better done by this particular human agent. Or it could go vice versa. So the agentic runtime is pretty much doing A/B testing with agents, and it doesn't care about the type of the agent. Rather, it cares about how well that agent is performing in this context. And the issuer doesn't know who was doing the task. They just say, okay, I want to have this. This was just a better solution, and then the agentic runtime will backpropagate, do its thing. Okay. Now we come to the thing I was going to come back to. Right now, the thing is written in C# and some Python for interpreters. But the way this would be done is, let's say if you have a C++ compiler, you kind of want to have it written in C++. If you have a C# compiler, Roslyn is just a rewrite of the C# compiler in C#. So ideally, you would want to have the agentic runtime written in agentic program prototypes, right? That'd be ideal. That means this is pretty much coming back to my initial slide. It's very difficult to discern which parts of this system are code and which are people. In a way, if you've rewritten the entire orchestrator framework, you've created a hybrid organization in which you cannot distinguish between what is technological and what is human in the loop. And this is an illustration, I think, of what that means. Typically, you have technology that facilitates communication, but where we see this advancing is technology is in a way more integrated, more predictive. It's just a continuation of how we behave. What we're seeing is that systems that exhibit higher intelligence are those systems whose components are more integrated. Like, they communicate with higher bandwidth. And without going into too much detail here, I would say that the biggest takeaway, at least from my own research so far, is that the more coupled the system, the more singular the intelligence. I don't view intelligence as like an agent having intelligence. It's more like a permeating field, right? It's almost like a measure of entropy convergence. Those components of the system which have more information flowing into them, those exhibit higher intelligence. And I'm going to leave you with this one. The more coupled the system, the more singular the intelligence, and hopefully I'll see you next year and we'll discuss the details of that. So that's it from me for today. Thank you. Perhaps?
Yes, enough time for other questions. Yes, please just wait for the microphone once again. Thank you.
Mm-hmm. And be as technical as you can.
It's very interesting.
Thank you, sir.
Project. Can you help us a little bit? I'm an engineer, but for public.
Mm-hmm.
Can you give some possible example of usage of this? Some factory or company or who give whom task?
Who would? So say we implement this, and how would it flow? Okay. So I'll give you the example that is least science fiction at the moment. So let's say you had a Teams bot that was connected to our agentic runtime, and the Teams bot's task is to render. Let me just try and come back to one of these. So let's say something like this. This arrow that's pointing from A5 to this shared prototype. This is global prototype memory. That arrow is actually, in this case, we're talking about a Teams bot. So you'd never, as a human, you never know that this is happening. But when you send a message, it's not going to go into a conversation. It's just going to get inserted into this global XAML repository. And if there's a user at the other end, human user, say, then that's going to be the agentic runtime is going to interpret that XAML tag and render that as a message being sent to them. So in this case, Teams bot is an adapter to agentic runtime. However, you could do this. You could type, I want to have my presentation translated to French. Okay, and you type that. You target either an agent with a name or a routing agent, which is something that you would be doing traditionally. And the routing agent decides, do we have a competent agent for this or not? So it may forward that to a human, like through a message, or to an LLM or other set of agents. And the A/B testing thing, here's how I would exemplify that. It does both things at once. Sends it to a human, sends it to this AI, retrieves both results. Presumably they haven't timed out and all of that. And then the issuing agent said, the issuing person says, okay, this one is better. And next time, this will be rewarded. Whoever wins. That is the flow. Did that answer your question? Any other questions? We have like 7 seconds.
Yeah, we have some more time. If there are any questions, please don't hesitate. Yes, there is there.
Okay.
Hi, great topic, great talk.
Thank you,
do you see this going to home PCs? Or it is just for companies and industry?
I see this coming to your home
in some
PC.
future, no in 1 year.
I'm going to try not to devolve this into a huge discussion. I think it's going to start with enterprises first,
yes,
because it's more useful there. The issue is when it comes to your home, you have other problems. Because I ended this presentation with the more singular, the more coupled the system, the more singular the intelligence. If your system, if your home PC cannot be well computationally integrated with whatever cloud is in the background, it's more going to be serving as an interface. And we see this as a shift globally. Like server-side rendering is a kind of current time expression of what I'm talking about here. So when it comes to your PC, you're likely not going to do compute on your PC.
Yes.
You see what I mean?
Yes.
Whether it's going to also come indirectly. The web pages are not going to be using This is my hypothesis. I think I'm right here, but again, I might be wrong. I would say web pages are not going to be done through traditional front-end engineering, because the agentic runtime is going to be the front-end engineer. It's just going to ad hoc just show you the exact UI you want to see. So when you and I visit the same website, we're going to have our own adapted UI. And this is already happening. This has been my argument for a while now. You want to have dark mode, all of that stuff. You want to have accessibility. It has to obey your browser settings and all of that. That's a kind of initial step towards this integration. I'm by no means presenting you with a final solution. We wanted to show that this is technically feasible, and I think it's quite inevitable. Now, what the actual implementation is going to be, we're going to see, but I think it's actually going to start this way. We're already building this operating system. We're not going to build it top down, we're going to build it bottom up. So, yeah, I think, in short, I think yes, but not so soon. First, you're going to see it in enterprises.
Thank you.
We have time for more questions. We have one question here, right-hand side.
Also, while we headed there, the biggest problem with this is when you have a lot of nested elements, the LLMs are not capable of let's say you had an LLM which wanted to, sorry man, I'll answer your question. If an LLM is trying to build a different agent, and that agent is an agent building agent, that means there's three levels of abstraction happening, and sometimes the model, oftentimes the model confuses which instructions are for these building agents and which are for them. And the reason for this is because they haven't been fine-tuned for XAML. We have to undo the fine-tuning for turn-based conversation and then introduce this. And it's a hack. We don't have the money, not like just HTech. Most companies on the planet don't have the money to do that. But my guess is that the larger players are going to do this because they know this is the way to do it. Not necessarily exactly this one, but likely some form of a XAML, and we see it in prompt engineering anyway, like Anthropic is doing this. Sorry, man, please.
No worries. So my question is, the highest bandwidth communication between humans is face-to-face, followed by video call. And I know you can say, all right, we'll just do speech-to-text, and that can go into an LLM. But I feel like that doesn't really capture everything. Is there something being lost there? Is it worth it? Or are we just waiting for AIs that are, based directly taking the video?
Okay. So if your question is this worth making at the moment, my answer is a resounding no. This is coming from R&D. We tried it to see what it's doable. Capabilities are kind of there. The cost is absolutely not. This will cost you many more times than a human operator. So that's the trade-off. Regarding bandwidth, without going into the discussion Neuralink and whatnot, I don't think, if you have systems that are energy efficient to pull this off, likely humans will be very rare in this system. That's my prediction, because of the bandwidth. So again, coming back to this statement, the more coupled the system, the more singular the intelligence, which means, to me, from my research so far, intelligence is, among other things, but primarily a measure of generality. So intelligence and kind of AGI is, to me, complete nonsense. Your intelligence is the measure of how general a system is. So if you can't integrate fully with that system, you can't participate in that sort of collective intelligence. And I see it, you're either going to choose some interface, like the Neuralink, that's going to enable you to operate with this more integrally, or you're just going to be kind of, laid to the side. That's how I see that happening. And you're absolutely right. If we don't improve our bandwidth, we're going to be left out by these systems. But I would also be very careful on that side, because if we improve our bandwidth, we also change our phenomenology. I've been talking about that for a while. The human experience also changes along with that. So I would be careful. Does that answer your question?
Yeah, and a second question you've kind of partially answered by saying humans will be more left out.
Yep.
But you mentioned A/B testing with human in the loop in A and no human in the loop in B. How does that impact on company morale, and if B gets selected and the human's wasted his time?
Okay, I should have prefaced this presentation with that. There's 30 minutes I have, so I cannot possibly cover both things. So today I aimed to do just the technical side. I'm absolutely not talking about the rights or wrongs of this. There are plenty of issues with doing that. Today I just didn't want to touch on that topic. My personal opinion doesn't matter here. We also, last year I believe I talked about something that I called concrete ethics, where you just try to make these systems as agnostic to local ethical principles as possible. But whether this is going to have a negative impact on morale, that's debatable. Because if you give people a choice over this, as long as they're not economically unstable, people are generally going to prefer being lazy over having to work. So the issue is whether you want to retain what humanity represents today, or you want to integrate into a more collective form of intelligence. And I don't think there's a third option here. That doesn't mean we're not going to be useful. I know this is a very lame metaphor, but the human body cannot work without its microbiome. And the microbiome is not directly integrated, like the neurons are, but it's still an important component. I know it's not a great allegory,
it's
but
not conscious, though.
Ooh,
okay, maybe.
We don't have that.
Okay.
That's a great topic, but I think the most profound effects of us researching AI in the next decade, say, are going to not be technological, but I would say more philosophical or related to ethos. Because I think the insights we are going to come to regarding consciousness are going to be quite different from what we thought before. I've written on my website about that. If you're interested, I know this is a shameless plug, but you can go ahead and read my opinion there. There's just no way for me to elaborate all of that here without, losing track. So thank you for the question, but it's just there's no space to answer that.
By doing this, what you think about Elon Musk still? He wants universal basic income.
Yeah.
20% of average salary for every person. This is perspective.
Here's what I think is... Here's what I think is most likely, and probably would be most stable long term. If you introduce a kind of taxation on automation, so if you want to be a company that automates, you pay a kind of tax for that automation, and that tax returns to the people, to the society, through universal basic income. Now, this is a very nascent idea. We don't have... For that to work, this would have to be much cheaper so that the company would gain something and the people would gain something. We want to have a kind of automation in which we have Pareto advantage, right? We want to have... by introducing this, we want to introduce a Pareto improvement, if everybody's familiar with that. Pretty much everybody wins. We want to have society win and companies win. Companies are part of society, but you see what I mean. So yes, universal basic income is the way to solve it, but we have to define the threshold of what it means that you're doing automation, because we're all doing automation already. Since our ancestor first picked up a piece of sharp stone and started cutting, that's the first step in automation. So yeah, the problem is going to be more cultural, like where do we draw the line of what is machine intelligence and what is human, or what is machine automation and what is human automation? Does that answer the question? Thank you.
Thank you very much. Yes, Igor Sevo, ladies and gentlemen, this is for you. Thank you so much.
Thank you.
Thank you.
Thank you.